Howdy! Today we're going to talk about what is engineering. So first off, a little bit about me. My name's Hawkins. I'm an ocean engineering student here at Texas A&M Galveston. I was originally born in Alaska, but now I've lived in Texas for about 16 years, so most of my life. I'm a class of 22, so that means I should be graduating next May. And my major, like I mentioned, is ocean engineering. So these are some pictures from the company that I'm going to be working for in May. This is a project called Deep Purple, where they use offshore wind farms to generate hydrogen on this offshore platform here and store it down below. So as they can use it for a battery to extract the energy back out of it. And on the right here, we've got an ROV, one of their special world-class ROVs. It's called the Gemini. It's got a lot of cool tech on it. These arms for manipulating. These are thrusters for moving yourself up and down in the water column. Just a really cool project. So, a little bit about the presentation. We're going to talk about what is engineering. We're going to talk about the tools that an engineer has and the different disciplines of engineering. So, what is engineering? Engineering is solving problems using science. So, you're trying to solve, in this left case, how do you turn electricity into motion, right? This is a motor right here. We've got coils of copper, we've got magnets in the middle here, and whenever you electrify this thing, it starts spinning. The problem in this case would be, how can we move something without having to use our bodies? And this is how we harness electricity. On the right here, we've got an LED, or a light-emitting diode. So this turns electricity, coming in through these two here, up onto this special semiconductor, generates light. So you put electricity through it and light comes out of it. The science here is, in this case, we're using physics. In this case, we're using electrical and chemical analysis of these specific materials that can change electricity into something that we can use. So in our toolbox as an engineer, we have math, science, chemistry, physics, and a bunch of other things. So, math is the basics of, if we need to generate a sine wave right here, how exactly will we do that using electricity? Or if we need to do something even more simple, like something in science. So science is the entire toolbox of chemistry and physics and the all-encompassing idea of harnessing our knowledge about the natural world to get stuff done to make our lives easier. Chemistry, another subset of science. How do you use special chemicals, special materials to get stuff done that you want to do? How do you make a new type of plastic or a type of rubber that you want to use on tires? Anything that you want to get done, you can do that with knowing the basics of chemistry. Physics, how things move, how momentum is transferred between the pull cue and the original cue ball. And simple machines are a great way to understand the mechanical world and harness it to do work. So in this case, the inclined plane, right, is the simplest form of turning horizontal work into vertical gain, right? All we're doing is pushing, but at the end of the journey, our box is higher up top. A wedge, which exactly looks like an inclined plane, but in this case, we're using it on a more micro scale. So the very tip of this axe is a wedge, or a knife is another example of a wedge. A lever, right, this looks like a seesaw. This is using a distance from a fulcrum, that's that middle point there, in order to do work. So to just barely tuck this hammer under the nail, and then you can give it a moment arm from the top, and you can generate more force whenever you're farther away from this nail right here, this distance. A wheel and axle, right? In a car, we generate what we saw in the motor is generating rotational force, and how do we turn that into distance moved? A screw, which is really just a wedge or an inclined plane that's wrapped around a cylinder here, and we can use that to secure lids or to drill this into wood to increase the amount of friction so that the screw doesn't come out of the wood. A pulley, which can translate motion, in this case, instead of horizontal to vertical, this can just go straight vertical to vertical, or at an angle, some sort of strange angle. You can make it exclusively pull upwards, like a flagpole, like tying something up. Now here at Texas A&M, there are 22 different disciplines or majors of engineering here. So why would you even want to break down an engineering project into smaller subsets? It's because sometimes you need somebody who is really good at one small little fraction of it. So if you want to build a nuclear power plant, you're going to need somebody who specializes in learning all about how atoms work and how they interact and how can we safely build a power plant out of it. Or you're going to need somebody that knows specifically about the ocean because you want to put it near the water so that you have a water source to cool down your reactor. Now, this is a great example. So this is a Chevy Volt. It's a car. You would think you could probably have one person that knows about all of these systems, but it's too complicated, unfortunately. So you get a bunch of people who are smart about their one little area, and then you combine all of their powers together to make a full product like this. So for the headlights, you're going to need somebody who knows electrical engineering, right? So that they can turn the electricity that you have on board into light. For the tires, you're going to need a chemical engineer who knows how to specifically design the right type of rubber to grip the road properly and not slip whenever it gets wet. For the battery, here in this case, it's at the very bottom of the vehicle, you're going to need another chemical engineer who specializes in the battery technology and exactly how much lithium and cobalt you're going to have inside your battery and how much power it can produce for you, and therefore how much power these headlights can use and how much power you can put into the motors to drive it. So breaking the project down into a bunch of different subspecialties allows everybody to be really good at their one little area. And the one reason that I picked ocean engineering is because I really like the ocean and I wanted to be the person who's really good at the ocean related subsystems. Well, anyway, thank you very much. I hope you have a good rest of your week.